Let's talk about relationship between x and y. So that's called a relation. So how many types of relation we have? Okay, we have four types of relation. Okay, so what are these types? So we have word to word relation. Okay, we have two words to select for each box. We have many or one. Okay, it can be a combination of one-to-one relation. It can be one-to-many relation. It can be many-to-one relation, or it can be many-to-many relation. So basically, there's two boxes and there's two words to put into each box, and you can pick like what one-to-one, one-to-many, many-to-one, or many-to-many. And that's the four types of relations we have. So how to decide? How to decide which one is one to one, which one is one to many? How to decide the type of relations we have? So first of all, we need to have the graph. Okay, we need to have the graph. Well, you can think like logically, but it's really, really hard. So if you have the graph, it's much easier. The first thing is you have your graph. Second thing is draw horizontal lines. This decide the first bracket. The first place. Okay, so whether that is a one or that's a many. So, well, I'll explain that later. So first I will draw vertical lines. And that will give you the choice of the second place. Okay, so whether the second bracket is a many or is a one. Okay, you know the choice of the first and the second. You know what kind of relation is that. All right. So what's the first bracket? What decide the first bracket? Is you draw horizontal lines on this graph or any graph you have. Okay, so you can draw horizontal lines, a lot of horizontal lines. Or anyone can for example, that's a ruler. No, that's a ruler. Horizontal line. So I just move down my ruler and see how many times my ruler intersects with my graph. Okay. Anywhere I put my ruler on this graph, it only intersects once, right? Is that right? Yes or no? How many times can it intersect with my graph? Like only once, anywhere, right? No. Right. Okay. How many times? How many times is that a ruler? You can draw horizontal lines. How many times this line intersects with my ruler? Twice. How about this place? No, the top end. One. But and two here, so two, right? How many times if I put my ruler here? How many times this line intersects? Infinite many times. Here's the overlap, so it's infinite many times. So the rule here is if anywhere it only intersects once, the first bracket will be 1. If anywhere it intersects more than once, anywhere, not necessary to be like a couple of points, like anywhere it intersects twice or more than twice, it will be a many. No, vertical. Second. Well, this is a function, but not because of the horizontal line test. Yeah, vertical line test is that is functional. Okay, and we do the same thing for vertical, like for the second bracket. We use vertical lines. Okay, how many times does it intersect? Anywhere. Once, right? How about that one? One. How about this one? Once. Even though the horizontal intersects twice, so the vertical intersects twice. How many times does this one intersect? And once. And if we look at function at the bottom, the relation at the bottom, how many times this one intersects? Twice. And once here, right? But somewhere it intersects more than once. And how many times here? Twice. Okay, so it intersects twice. So this one, those two will have a many on the second bracket. Okay, second bracket. So basically you put horizontal line first and that tells you the result for the first bracket. And you put vertical lines anywhere and it tells you the result for the second bracket. So basically I want to choose between the words one or many. So if it intersects anywhere only once, then that's a one. If it intersects more than once at any place, that will be a many. So that's how you decide what kind of relation you have. Okay, so for example, this circle, like you have a circle, we learn how to draw circles. So if you draw a horizontal line here, it intersects twice. So the first bracket will be a many. And if you draw a vertical line here, that will still intersect two places, and that's a many here. So that's why you get a many to many function. That's a circle. You will have you will see questions asking what type of relation you have for a given graph. Okay, so you need to draw horizontal lines and vertical lines to decide what kind of graph you have. I just want to explain a little bit what the first bracket means and what the second bracket means. Okay, I'll explain start from the second. What this many means? Because what this one means? The second bracket means okay, the second place. One x value only give one y value. Okay, that's one means. And if you have many here, that means one x value. Can you stop talking, guys? I can't remember what I was to say. One x value gives more than one y value. So for example, if I sub x equals to 2, if there was a 1, I now have y equals to 4 only. But if it's a many here, for example, I sub 1 in this question. If I sub x equals to 1 in this question, I will have y equals to 0 or y equals to 2. I will have two different y values. Okay, so for each x, you only have one y value. That bracket is a 1. If it's a many, means when you start x, you can have more than one y value. Like y can be 0 or y can be 2. So that's a many. Okay, that's the meaning of many. So for the first one, is the other way around. Okay, so it's the other way around. If that's a 1, means you sub one y value can only solve out one x value. Okay, you sub y, it's different, it's the other way around. The second bracket means you sub one x in, you have one y or you have many y. And now if you pick a y value, sub into the equation, how many x you can solve out? If it's a 1 there, you can only solve out one x. If it's a many here, okay, sub one y value in, get more than one x value. You get more than one x values. Okay, so it's basically substitute and then get a y value or substitute y to get x value. How many x you can solve out, how many y you can solve out. Okay, that's the meaning for those two brackets. And if you see that from graph, you can just go horizontal line test and vertical line test. Okay, let's have a look. This one is a really interesting one. So there's no graph. It's a mapping diagram. There's no graph, and I want to think about what kind of relation is this one. All right, let's have a think. For the first bracket, like what to what? I know I give you the result already, but let's rethink about it. So the first one is sub y, solve x, and the second one is sub x to solve y. Okay, now let's think about the first bracket. When y equals to d, what x you can solve out? When y equals to d, what's the x value? 1. When y equals to b, what's the x value? When y equals to b, what's the x? 2. When y equals to c, what's the x? 2. When y equals to a, what's the, let's map here. When y equals to a, what's the x? 4, right? There's only, it's one, like when you give a y, only give one x. So that's why the first bracket is a 1. When you say a y value, I can only alter one x value. That's a 1 here. Okay, y sub x, y equals to d. Okay, no problem for this one. Y sub x equals to 2, what do you get? B and C. So you get more than one y value when you sub each x in. So that's why the second place is a many. And that's why the second place is a many. When you sub y in, each y value, you can only solve out one x value. You won't say when y equals to b, x equals to 1 or 2. I didn't get that. So that's why the first one is a 1. And when I sub x equals to 2, I get y equals to b and y equals to c. I got two y values. That's why the second place is a many. So that's a one-to-many relation. And that's a one-to-many relation. All right, go to the next page. Well, the whole paragraph here is explaining how to do the test, how to find what kind of relation is that. If you forgot, you can just read that. So now let's talk about what is a function. Okay, so there's 4 types of relations. There's 4 types of relations. There's one-to-one relation. Oh, I read it smaller. So one-to-one or many-to-one or one-to-many or many-to-many. Okay, there are 4 types of relations. That's the 4 types of relations we have here. And then 2 of them are called functions. The first 2, those 2 types of relations, they are functions. The other 2 are not functions, okay? So function is a subset of relation. Only some kind of graph, they are functions. Not all, any graph can call a relation, can be a relation. But only one-to-one or many-to-one relations can be a function. So why, okay, you can see the pattern is one-to-one or many-to-one. The last spot must be a 1. Okay, the last spot must be a 1. Alright, so what's the definition for a function? Okay, the definition for a function is a relation such that for each x value, there is a unique corresponding y value. Basically means I sub x, sub one x value can only get one y value. Okay, so each x got a unique corresponding y. So which means y sub x equals 1, I won't get y equals to 2 or 3, like won't get that case. So y sub x, I know there's only one y value corresponding to that. So that's why it's a one-to-one or many-to-one is a function, not the other 2, and not the other 2. So I need the relation to be one-to-one or many-to-one to become a function. Which means it has to pass the vertical line test. Okay, it has to pass the vertical line test. When you draw vertical lines, you only intersect the graphs anywhere at 1 point. Okay, anywhere at 1 point. They are very dry definitions, but you just need to know them. Okay, functions are relations, but not all relations are functions. So functions is a subset of relation. Okay, function is a small part of a relation. Okay, let's have a look at this very tricky question here. If A comma B and A comma C are all the pairs of a function, what you can say about B and C? Very tricky. If A comma B and A comma C, they are the point or points on a function, what you can say about B and C? Yes, Josh? Problem, yeah. No, it's a function. Circle can't be a function. Circle is many to one, many to many relation can't be a function. Now, let's think about function. What's the definition for function? Each x must have one y value. So different or same? Same. B and C must be the same value because you start the same axis, you shouldn't get different y value. Like they must be the same point. Those 2 points must be the same point. Otherwise, there's no way to become a function. So B and C must be the same. Okay, must be the same. So what you can say about B and C is B and B equals to C, and actually they're the same point. They can't be different points. If they're different points that looks like that, and one x gives 2 different y value, it's not correct for a function. Okay, we're okay. That's function notation. Okay, function notation. What's a function notation? When I talk about that, like with you, when you draw a graph, what's the 2 things you require, like you need to know to draw a graph? Turning point is only true when you draw quadratic. Well, that's all the, like, different graphs got different x, y intercepts. Equation, okay, the first thing is equation. What's the second thing? I know the equation now. Why I have different graphs here? Like, wait, where is it? Here. I have the same equation. Why I have different graph? What's different? Why those 2 graphs looks different? Domain. Okay, good. So back to here. In my function notation, I need to know a couple of things. I need to know the name of the function. Okay, what's your name? I need to know the name of the function. I need to know the domain of the function. Okay, I need to see what's the domain of function. And I need to see the rule or say the equation of the function. Okay, I need to see those 3 things in one notation. Okay, in one notation. Let's just pick one example from the exercise. So when we sketch this one, y equals to x squared plus 2 and x belongs to minus 2 to 1. Okay, just take that one. I will just copy it here. Y equals to x squared plus 2 and x belongs to negative 2 to 1. Okay, that's the example we sketched last lesson. Now I want to put that into a function notation. So what's a function notation? Function notation shows those 3 things. If you haven't learned that before, I think you need to write this down because there's no examples really given function notations. Okay, so what's a function notation? First of all, the name. So what's the name? You need to give a name, like I don't like Y. So the new names can be F, G, or H. Or can be R, can be L, like, but F, G, H is the common use ones. So now I say, okay, I give you a name. I name your F. Okay, so first of all, I'm talking about function F. Put a colon here means I'm explaining who is F, okay, or the character or the special things about that. And the next thing, okay, following the order is the domain. I need to see what's the domain. Knowing that domain is negative 2 to 1, so I put the domain here in set notation. Okay, in set notation. Not like interval. Interval notation. Okay, put in set. So that's the interval from negative 2 to 1. Okay, all set notation, that's fine. So that's my domain. And the next thing I'm going to write is the same. Okay, so for all the function notation. So it's always there. Okay, so it's a fixed notation here. It's an arrow, right hand side arrow, and write a R here, and a comma followed by that. Okay, what's this arrow and then R means? Is the range is mapping to the real number plane. So it's not real, like nothing really important to you. Okay, so it's just a fixed notation. It's always there. You don't really need it. That's just how you should write your notation. So -2 to 1 mapping to R and comma. So I'm talking about the next thing now. So the next thing is, what is the rule? Okay, I want to see the rule. So the rule, I still repeat the name. So name is F. And then I need to give my variables. So my variable is X in this case. Okay, so bracket variable. If your variable is A, you should write bracket A here. So that's your variable. Fx is x squared plus 2. Okay, so the name of the function and the variable, what is changing? So these two things is actually equivalent to y. That's just y equals to x squared plus 2, nothing different. Okay, so you have y of x equals to x squared plus 2. So overall, all of these, that's a function notation. Okay, that's a function notation. So all the things I'm writing here, they are function notation. So if you can turn the page back to page 5. Can you rewrite those two things into function notation, please? Okay, those two, page 5. I want to see the function notation for those two. Okay, everyone, I'm trying to write that. Page 5. Give you 1 minute to write that. Function notation. You can give any name, F, G, or H, doesn't matter which one. So you pick a name, you follow the steps. Okay, what is next? Well, the second one is easy to write, so you can do the second one first. Easier, not easy. Okay, I'll randomly pick someone to show it for me, okay? Make sure you know how to do it. Which one first? This one? It can't be comma 1 to 4 because it's not from 1 until 4. It's only 1, 2, 3, 4. Yeah, you can't do the interval notation here. I'll show you the. Which one I'll show you? I'll show you the second one maybe. Second one, I can say that's a function g. What's the domain for g? Peter, what's the domain for g? Yeah. Yeah, domain for g. Okay, so give me one letter. R. Okay. Domain is R. X belongs to R, so domain is R. And then there's a fixed notation, R mapping to R, comma. The name of the function is g, so it's gx equals to x plus 1. Someone else will do it for me. Yeah. Who's the lucky one? You want to try that? Who's kind person who will do that for me? Yeah. Yeah, F is your function. F. Yeah, so 1, comma 2, comma 3, comma 4, and what kind of bracket we use here? Yeah. And then what we have? No, something missing after that. Arrow on, comma, and then yep. Here, get it? It's not that hard. It's just like domain and rules can be seen in the same line, and it's more. I say it's a more mature way of expressing this, but there's no difference compared saying y equals to something, and then domain is that. Okay, so it's just no. I think yes. Yes or no? Let me check. Yes, then yes. Up to C, up to C. C is the function notation, yeah. Okay, so after you write fx, like I want to just talk about what's fx. I think most of you know that, but I just want to talk about that again. So if we have y equals to x plus 1, for example, okay, no, not right here, let's write here. So for example, y equals x plus 1, and I write fx equals to x plus 1. Okay, what's the difference between those two notations? No difference. But just like when we substitute values, it will be easier to do the substitution. For example, for y equals x plus 1, I will say when x equals to 0, y equals to 0 plus 1, and y equals to 1. I will do that. And then I know the coordinates will be 0, comma 1. But for fx, what we can do, we can change the bracket into 0, so which means x equals to 0 in that step. And then all the x needs to become 0. And I know my f0 equals to 1. Someone wants to do the teaching instead of me? You? No? Okay, so my x value equals to 0, my y value equals to 1, still give you the same thing. That's still a 0, comma 1. So what you substitute into the bracket, that's the x value. And then whatever you get from that function, that's the y value. So 0, it's exactly the same. If you can see those two sides, it's exactly the same. It's just like we change y into fx or gx or hx. So we have this one. I don't want to talk about the 3 and minus 2 one. They are alright, because if I go f3, that's 2 times 3 squared plus 3. Like all the x will be changed into 3, and you do the calculation after that. The confusing one will be the fx minus 1. Will be this one. I change the x. Okay, basically means I change the x into x minus 1. Yeah, I change the x into x minus 1. So therefore, this will equals to 2. Okay, when I meet x, that x needs to be changed into x minus 1. When I meet another x, that x needs to be changed into x minus 1. So that's my x minus 1 equals 2. So that's 2x squared minus x plus x. That's minus x minus plus 2 minus 1. That's a plus 1. Oh, sorry, minus 4 minus 3. That's minus 3x plus 2 minus 1. Okay, so what is not a number? Basically, it's what you have in that bracket is the x will change into that thing, and you just replace all the x by the thing in the bracket. That's all you need to do for a function notation. All right. Well, the next thing is talk about function. Oh, that's the example. Okay, that's the example. So this is the set notation and how we can convert the set notation into a function notation. That's a for example here. So f such that domain is 0 to 4, mapping to r, comma fx equals to 2x minus 1. So that's a function notation. All right, last thing is a function is defined by two things. One is the domain and one is the rule, or say the equation. Anyone is different, then they are different functions. Even though they have the same rule. If you look at all the three graphs here, they have the same rule. Okay, the rule is x squared. But the first domain is R. Second domain is from -1 to 1. And then the third domain is 0 greater or equals to 0. Why they are different functions? Because the graph looks different. It's not the same graph. Like you can't say they're same because they look different. So they are all different functions. Okay, so you can circle the last line. Last line is we call G and H, the second and the third one, a restrictions of F. Because F is the whole graph, like with domain R, like it can be everything. But G and H is part of the F. You get G and H is part of F. That R represent range. But it's not means range is R, it's your range is in the area of R. So it's part of the number of R. Like that means like a core range or something like that. Like you don't really use that part. Like in higher study, like sometimes we change that part, but in method we don't change that part. Okay. We only talk about next page tomorrow, so you can just do some of the work today. So we finished C and mostly D today.